Good morning, one and all. Today we will discuss about cryptography algorithm, symmetric key cryptography algorithm, that is DES. Here, DES uses two basic techniques of cryptography, that is confusion and diffusion. At the simplest level, confusion is achieved through numerous permutations and means diffusion. And confusion is achieved through XOR operation. With simple mathematical operations. Confusion is strongly binds with XOR operation. Diffusion is strongly binds with permutations. Okay. So here, this is the overall picture of DES algorithm. In 60 here, the input plain text size is 64 bit, and key size also 64 bit. Related to key, the initially the key is permuted, that is permuted choice one, then left circular shift, then permuted choice 2, similarly left circular shift, permuted choice 3, and so on. And it generates different types of keys for different types of routes in DES algorithm. So here K1 is generated, and that is used to round 1. Similarly K2, K3, K4, and so on, and K16. So up to K1 to K16 will be generated. Those are the round keys. Those are called round keys, and those round keys will be used for different rounds in DES algorithm. That is about the key. And when it comes to the plain text, initially, the plain text size is 64-bit only, and initial permutation will be applied, and all 64 bits will be shuffled. Then round 1, round 2, and so on, round 16. And after round 16, 32-bit swap will be happened. And the last one is inverse initial permutation. Again, the bits will be shuffled. That is called like inverse initial permutation. But finally, it generates a 64 bit ciphertext. Now, this is the picture. 64-bit plain text block. But here, the 64-bit will be handled in two parts. First one is left part, second one is right part. Here, left part, that is L0, R0. Left part is 32 bit, right part is 32 bit. And here, all of you check it. The key K1 is derived from 56-bit only, not 64-bit. But initially, in earlier slide, you have observed the key size is 64-bit. From 64-bit, when it is divided into 8 parts, means 8 rows, the last row will be ignored. That is, every eighth bit will be ignored. So after deducting 64 means 8 bits from 64, it will become 56 bits. Okay, because every eighth bit will be ignored. So that is the reason 64 minus 8 rows means 8 bits. So total 56 bits will be generated. From 56 bit K1 will be generated. Now here, just all of you check it. L1 will become input for next round, and R0 will become input for next round, like that. Means purely we can say L1 is equal to R0. There is no other manipulation for L1. L1 directly uh, taking R0 but L0 and the K1 will be applied on XOR operation, and it will give something that will become R1. So similarly, you can find the remaining rounds K1 to K16. Okay. And finally, initially it is like initial permutation, and last step almost like IP inverse means inverse initial permutation. Means again, all 64 bits will be reshuffled. That is inverse permutation. So here, initial permutation will become like this. Means uh, 0 to 8 bits are there, means 0 to 7 bits are there, total will become 8 bits, and the bits are like this: 58 position, 58 position, 42 position, 34 position, and so on. And second row will become like 60, 52, 44, 36, and so on. And the third row, this 62nd bit will come, and 54 bit will come, 46, 46 bit, 38 position, 38 position will come. And similarly, the last row is like 63, 55, 47, and so on. But when you check IP inverse, actually, where is zero? Means that is like first row, first bit, that is 58. Then you can check, means this is like inverse. Means whatever bits are shuffled in IP, uh, the same thing will be happened in IP inverse. Means those bits will come their original positions. Okay. This is the picture. Whatever you have observed in initial permutation, suppose means zeroth bit is nothing but 58. Okay. So here also, just all of you check it. Zeroth bit will become 58. Okay. Similarly, suppose the first bit will become 50. First bit will become 50, like that. This is like initial permutation. Next, what about left part and right part? Just earlier also you have observed, the 64 bit plain text will be divided into two parts, that is left part and right part. But here, left part will become like no, right part will become like left part in next round. That is L1 is equal to R0. There is no other manipulations, no other mathematical formulas are applied on right side part R0. It will become like L1. Okay, that is 32 bit. But what about left part L0 and right side? You need to check, that is expansion permutation. Actually, its size is 32 bit only, but this 32 bit will be expanded to 48 bit. Just how the expansion will be happened, we will check it. That will become 48. Then here, actually the key size is 56 bit. From the 56 bit, a sub key will be generated and its size is 48 bit. So two inputs are there. One is expanded right part, that is 48 bit, and the key size is 48. Both the XOR operation will be applied on these two inputs. Then automatically the output will become 48 bit only. So from the 48 bit, again the S box will be applied, and the 48 bit will become again 32. Okay. But after that, P box permutation will be happen. 32 bit will become 32 bit only. There is no mixer. scale down or scale up, as it is, it will give the same size output, that is 32 bit only. Now again, this 32 bit and L0 will be applied with XOR operation. Again, the XOR operation will generate the output, and its size is also 32 bit. Now L1 is ready and R1 is ready, and again the same operation for next round also. The same thing, whatever we have discussed here, the same thing will be applied on means round 2, round 3, round 4 up to round 16. Means the process is, everything is common. Here the question is how the expansion will be happened. Yes, sir. Already you have observed in the previous slide, 32 bit will become 48. So here the 32 bit will be divided into 8 parts, 8 into 4 bits, total 32 bits. Now here 1 to 3 4 one set, 5 to 8 one set, 9 to 12 one set, 13 to 16 one set, and so on, 29 to 32 one set. Here all of you check it, how the 4 bits will be expanded to 6 bits. The 4 bits will be as it is copied to output, but 1 to 4 bits will become like 2 to 5 bits. 2 to 5, their positions are like 2, 3, 4, 5. But what about 1 and 6? So here the sixth one is nothing but first bit in next part, and first bit is nothing but last bit in previous part. Okay, means for understanding purpose you can check it here. The bit number 5 will become sixth one, and initial position means that is like initialization vector, that is like means that is for first round some constant will be supplied, that will become first bit. So total 4 bits will be expanded to 6 bits. Okay, so similarly input is 8 into 4 32 bit, and output is 8 into 6 48 bits. Okay, this is nothing but the expansion permutation. Next, encryption round. So here, uh, all 64 bits will be arranged 8 rows, is 8 into 8 total 64 bits. But here, uh, miss first one and last one. Okay, the middle one already you have observed. One, two, three, four will become second bit, third bit, fourth bit, and fifth bit. What about sixth bit? Sixth bit is nothing but first bit in next part, that is fifth one, ninth one, 13, 17, 21, 25, 29, and 1. But what about first bit? First bit is nothing but means that is like last part in first bit in last part, that is 32. 32. Okay. Next, 4, 8, 12, and so on. Okay, 28. This is like how the 4 bits will be expanded to 6 bits. Okay, or how the 32 bit will be expanded to 48 bits. Okay, next one. Next, what about XR operation? Just we have some idea on XR operation. 6 bits, 48 bits means it is divided into 8 parts, 8 into 6 bits. 6 bits will become 6 bits only, means input and output. When XR operation takes 48 bit and 48 bit two inputs, automatically XR operation will generate one output, that is 48 bit only. Next one. What about functionality of S-box? So here already you have observed the entire input is divided into two parts. 64 bit is divided into two parts, 32 bit and 32 bit. we will discuss how 32-bit block will be handled. So here for SBox, the 32-bit means for one part, that is 32-bit, 32-bit expanded to 48-bit, and here the size of the subkey is also 48-bit, and both will be applied on XOR operation, and automatically it will generate a 48-bit output only, and 48-bit will be divided into 8 parts, 8 into 6, 48 bits. Here every part has 6 bits only, first part, second part, and last part also for 6 bits only. But here S box takes 8 bits, and it generates 4 bits output. Okay, how it will be happen? We will check in next slide. Here, first part it takes 6 bits, it generates 4 bits. Second part it takes 6 bits, it generates 4 bits, and so on. The last part it takes 6 bits, and automatically it generates 4 bits. In every part, the size input size is 6 bits, and the output size is 4 bits only. Okay. After that, again permutation will be happen. In the case of permutation, it will the bits will be shuffled, and again the output from the permutation is 32 bit only. Okay, so here the overall picture is, in this picture, the input size is 32 bit, and the output size also 32 bit. Just all of you check the picture. So here for S box, means substitution box, the input size is 48 bit, but the output size is 32 bit. But how it is happening? Just once again, you can check the picture. All 48 bit are divided into 8 parts, 8 into 6 bits, 48 bit. So here 6 bits will be given to S box. Automatically, the S box will generate 4 bits only. Similarly, S box 1, 2, 3, 4, 5, 6, 7, 8. It's different S boxes, not similar S box, different S boxes, and automatically each S box takes 6-bit input, and it generates 4-bit output. So automatically the 48 bit will be reduced to 32 bit. Okay, how an S box works? Okay, so here 6 bits, 6 bits. All of you check it. There is no change in miss 4 bits. The first bit and last bit, Aditya. First bit and last bit. First bit and last bit will become, first bit and last bit will become, will give the row number. Okay, suppose if it is total 2 bits only, total 2 bits, how many combinations will be coming? To total 8 combinations. Okay, 8 total, okay, total miss 2 bits, so total 4 combinations, first row, second row, third row, and fourth row. Okay, like that. Okay, means 0, 0, 0, 1, 1, 0, 1, 1, total 4 combinations will be coming. Those 4 combinations indicates the row number. 0, 0 means 0th row, 0, 1 means first row, 1, 0 means second row, 1, 1 means third row, row number 3. So here, but what about middle 4 bits? Those 4 bits means how much it is? 2 power 4. 2 power 4 means 16. 16 means 0 to 15 numbers. Okay. So here each row contains 0 to 15 numbers. Means the middle 4 bits will be converted into decimal. The decimal numbers are like 0 to 15. Okay, so this is the overall picture. Means automatically it takes 6 bits input and it generates 4 bits output. Next, this is encryption. Means already you have observed in a previous slide. It is like S boxes. S boxes. Total 8 S boxes are there. Already I told each S box is different from others. Means those are not similar with substitution box. Okay, so the first S box it starts with 14, second one 15, third one 10, fourth one 7, fifth one 2, sixth one 12, seventh one 4, eighth one 13. So like that, you can find different numbers in different S boxes. Okay, no S box is similar. This is a permutation box. Means when the permutation box takes 32 bit and it generates 32 bit output only. But here, check the picture. So the first bit will become like ninth bit. The second bit uh, the second bit will become like 17 bit and so on, and suppose 30 second bit will become like 21 and so on. So this is the picture. Means like a shuffle the bits. Means all 32 bits will be shuffled. Okay, this is means final permutation. Means whatever shuffled in previous slide, means the bits will be placed in its original positions. Suppose first bit will become 58 gestation. So in final permutation, the 58 bit will become first bit, which quite inverse. Okay, quite opposite. Means 1 to 58 means automatically 58 to 1, or 2 to 16 initial parameterization. After that, 60 to 2. 2 to 16, 16 to 2, like that. This is initial key permutation. Initial key permutation. Same thing, total 64, already I told 64 bits will be there, and all 64 bits will be divided into 8 rows, and each row, the 8th bit will be ignored. Okay, total 8 into 7, 56 bits. So the input is 64 bit and the output is 56 bits. Okay, because one bit will be ignored from the initial key. Okay, now the key will become and its size is 56 bit. Okay, this is the picture how the bits one bit will be ignored and how the bits will become will be shuffled or selected, whatever it may be. Here, what about the key sub keys? Already I told the 64 initially the key size is 64 bit only, but the 64 bit is divided into 8 parts, and in each row the 8 bit will be ignored. Then it will become 56 bit, and the 56 bit will be divided into two parts: 28 bit and 28 bit, left part and right part. And here, the left part or right part, that is like shifted. Okay, shifted, shifted by left, means like left shift. Okay, but here the left shift, some calculations those are already fixed. If it is a first round, the left shift by 1. If it is a second round, left shift by 1. If it is a third round, left shift by 2, 2, 2, 2, and so on. The last round, the left shift by 1. Okay, these are different statistics related to left shift. Okay, and after that, the 56 bits will be reduced to 48 only. Again, you can check what type of bits are ignored from 56 bit. Okay, so the 56 bit will be reduced to 48 bit only. This is the overall picture of key generation. Here already you have observed in previous slide, the 56 bit is divided into 28 bit and 28 bit, and left shift, and permutation will be happened, and it generates one output, that is Ci, and right side it generates one more output, that is Di. Okay, and these subkeys will be given to the encryption function. Okay, for encryption function, this is the input to the XOR operation, and in left side you can check it. In XOR operation, it takes two inputs, one from the expansion, second one is subkey. Both size is 48 bit and 48 bit only, and after that, already we have discussed. And here permitted choice one. Okay, already you have observed in the previous, what is that? Okay, here you have observed permitted choice one, permitted choice two, permitted choice two, and so on. Okay, initial permutation is permitted choice one, and the remaining are permitted choice two. So this is nothing but the permitted choice one. Means those bits will be shuffled like this. Okay, so total 16 numbers in a row, total 16 into 4, 64 bits. Okay, first bit is nothing but 57 bit, second bit is nothing but 49 bit, third bit is nothing but 41 bit, and so on. The last bit is nothing but fourth bit. Okay, that is original one. This is after permutation. Similarly, PC2. PC2, every time the 14 bit will become first bit, the 17 bit will become second bit, the 11th bit will become third bit, and so on. And 32nd bit will become 32nd bit only. Okay, Miss 32nd bit will become 64 bit. Okay, these are the numbers. This is permitted choice 2. Now key rotation. Already we have discussed. If it is a round one, key rotation is means left shift. How many bits will be shifted to left? That is one position only. Similarly, for round two also one position only. Round three, two bits. Round four, two bits, and so on. In 16th round, it is like one only. Okay, total it will become 28 rounds. 28 left shifts will be happened. So this is the table. You can check it, round number 1 to 16, and how many shifts will be happened in each round. But anyway, the total left rotations are like 1 to 28. Okay, total 28. Now what about decryption? Here, the same algorithm as encryption only, just reverse the order of the key. For example, IP underscore IP inverse in encryption, and the quite opposite, IP inverse to IP. Okay, first round with S16 undergoes 16th encryption round. So anyway, decryption. This is like quite opposite. What are the strengths of DES? Here, reduction in key size of 72 bit, too short to withstand with brute force attack. But here the bit size is very limited. So nowadays the computational power is very high. So that is the reason, miss cracking the key. It is not a big issue in today's technical world. Maybe that is one of the limitation in this case. Second one, S boxes were misclassified. Weak points enable NSA to decipher without the key. Means here S boxes also, those are not dynamic, those are static. So when static means automatically we can apply some calculations and we can analyze the data. And the third one, 56-bit keys have 256, 2 power 56 only. That is like 7.2 into 10 power 16 values only. Means brute force it looks little bit hard, but it is cracked. And DES was proved insecure in 1997 on internet in a few months. In 1997, in those days, the computational power is very very less, even though the DES was cracked. In 1998, on dedicated hardware in few days. In 1999, in 22 hours only. Okay, so this is the thing. Miss, when we talk about 1999, but when we are in 2025, so now it is like almost negligible. What is the strength of DES? Avalanche effect in DES. If small change either in plain text or the key, the cipher text should change drastically. So, how it is happening in DES, we will check in different rounds. In the plain text and key. Suppose change in the plain text. How many number of bits that differ? Suppose in round 0, that is 1 bit is differing. In round 1, 6 bits. Round 2, 21 bits. Round 3, 35 bits are differ. Round 4, 39. Round 5, 34. Round 6, 32. Round 7, 31. Round 8, 29. Round 9, it is 42. It is good number. Round 10, 44. It is also good number. But after that, it is keep on decreasing. Means round 11 it is 32, round 12 30, round 13 30, round 14 26, round 15 29, again increased in round 16, that is 34. So these statistics, when there is a change happened in plain text. Okay, when there is a change in one change in plain text, means according to rounds, how many bits are differ. And second part is a change in the key, means how many number of bits that differ when there is a change in the key. Means round 0 0, round 1 2, round 2 14, round 3 15, means 28, round 4 32, round 5 30, round 6 32, round 7 35, it is increasing, round 8 34, round 9 40. Okay, so after 9 10 rounds only, we can find some best values. After that it is keep on decreasing. Means here round 10 38 and so on. Round 16 it is like 35. Means more or less in both cases, means the number of bits are almost like similar. Means when change in plain text or when change in key, in both cases it is like anyway, it is more than half of the bits will be changing in DES. So according to avalanche effect, the DES performance was good, but according to brute force attack, strength is very very less. The plain text that is like 64 bit, and the key size is 56 bits, automatically generates some cipher block. So here trying all 2 power 56 possible keys is not that hard in these days. That is not good. And If you spend $25,000, you can build a DS password cracker that can will succeed in a few hours. And in 1975, this would have cost a few billion, but it is widely believed that NSA did this. But that similar algorithms with longer keys are available in today's market. That is, its name is like IDEA algorithm, and these are about the DES algorithm. Now we will discuss about AES algorithm. Here, the slides I have taken from internet, thanks to the Miss author of these slides. So here, AES is a non-physical structure that encrypts and decrypts a data block of 128 bits. It uses 10, 12, and 14 rounds. The key size, which is like 128, 192, or 256 bits, depends on the number of rounds. So here, the generation of AES encryption cipher. Here it is the plain text size is 128 bit, and pre-round transformation, round one, round two, and so on, round n. Because there is no fixed number of rounds, we can take any number of rounds, and accordingly the key size will be fixed. So here 10 rounds 128, 12 rounds 192, 14 rounds 256. Which in this algorithm, means the number of rounds and the key size is not fixed. It depends on the logic only. Here, the cipher key that is like 60, 64 means total words are means these are the number of words W0 to W3 means that is like 16. One word size is 4 bits and so on. And the plain text means that like that is add round key. We will check what is add round key. And each round 1 to round 10, means some fixed functions are there. Sub key bytes, shift rows, mix columns, add round key. These are the four functions are common in each and every round except the round number 10. In round number 10 you cannot find the function mix columns. Okay. Similarly, in the same means operations will be happen round 10, round 9, and round 1, and so on, round 1, and last one at round k. So automatically, it converts plain text to cipher text to plain text. Now here, this is the picture when there is a plain text, and the plain text that is like 16 bytes. 16 bytes. Those 16 bytes are converted to 4 by 4, means like 2 times clear, and initial transformation will be happen, and after that the 16 bytes will become like 16 bytes only. Next round 1 will be started and so on. It will continue up to round n. After that the final state will become like 16 bits, and the 16 bits will become like means one dimensional array, that is ciphertext. Okay. uh, On the right side, you can check it. The key size is M bytes. M bytes means the key size like 16 bytes or 24 bytes or 32 bytes based on the number of rounds. Okay. And here, whatever you have observed in previous slides, this is the actual picture. The byte B means that is like 8 bits only. 8 bits will be converted like array, and word means those are 4 words. Those are converted like array, and block means total 16. 16. Those are divided into 4 parts, and these are the numbers H0, H01, 0001, 02, and so on, and S 3, comma 3, and it is converted to word 0, word 1, word 2, word 3, and changing plain text to state. So here A is converted to like 00, E is converted to 04, and so on, and up to Z, and those are converted to the two-dimensional array. Now this is input block 0 to 15. Now those 15 means bits are divided or rearranged like this. Means 0, 1, 2, 3, means column wise, 4, 5, 6, and so on, and 12, 13, 14, 15. Now, means the positions are like X00, 01, 02, and so on. Last one is X33, means row number 3, column number 3. Now, the first round, that is like substitution box, means substitution bytes, shift rows, mix columns, and add round key. Means this is the picture when 16 bytes are converted. So here, substitution bytes transformation, and that is like S box only. S box. Substitution bytes means S box only. So here, AB16 means A indicates row number, B indicates column number. Okay, suppose if the input is like 04, 04 means 0th row, 4th column, like that. So automatically each and every means input converted to like this. Suppose this is the picture 55. So here 55 means fifth row, fifth column, and the output is like FC. Okay. Now FC. Okay. So in inverse substitution box you can check it. Where is FC? FC means that is like where is FC? FC. You can check it FC. Again, it will come 55. Okay. FC. Now, if the input is like 00, 1 to means 12, 0C, and so on, and those are converted like this, means substitution bytes. When the input is like this, the output will become like this after yes by substitution bytes. The second one is shift rows. Second one is shift rows. So here, uh, what is the logic here? For zeroth round, there is no shift, but round one byte shift, round two byte shift, round three, miss that like row three, 3 byte shift, like this. Just always check it like this. Okay. So here, uh, there is no change in row 0. Uh, one byte change in row 1, 2 byte change in row 2, 3 byte change in row 3. Those will be added like this. This is like left shift. Suppose this is the example. Uh, when 63, C9, and so on, there is no change in first row, but in row 0, but you can check row 1, one shift left, that is F2 will be moved to right side, and here C9 will be moved to right side, and FA 6382 will be moved to right side, and this is the input, and the right side one is the output. You can check it. Next, mixing bytes using matrix multiplication. So here, this is the picture mixing bytes using matrix multiplication, and AX plus BY plus CZ plus DT. That is like that is a combination of two matrices A, B, C, D, E, F, and so on, and right side one more, that is single column X, Y, Z, T. Some of the constant matrices used by mixed columns and inverse mixed columns, and whatever you have observed, this is like what that multiplication, constant matrix, and this entire column will be multiplied with constant matrix. Then it will become a single column only. This is the actual multiplication. And here, suppose 63, C9, and so on will become 62, 02, 27, 26, and so on. Okay? Means after multiplication. Next, add round key. This is like XR each byte of the round key with its corresponding byte in the state array. This is like round key, and the actual input both will be given to XR, and output will become like this. Input is like S01, output will become like S dash 01. This is the picture. Add round key. This is the picture. State, substitution bytes, shift rows, mix columns, add round key. This is the overall picture of each and every round. Okay. Here it is key expansion in AS, cipher key, K0, K1, and so on, K15, and these are some operations, and it generates the final key. These are like some calculations around keys and so on. Okay, just this is the example. When there is a plain text 00, the cipher key is miss 24, and the cipher text is BC. Like that, it is converting. Just this is about single state. When the input is 18, after substitution bytes, it will become 7C. After shift rows, it will become C4. After mixed columns, it will become 2A. After that, it gives some output that is 01. So like that, you can check how the input is converted to output. Means this is like single round. Like this, you can find different number of rounds are there. After completion of all the rounds, you can find the cipher test. Okay. So up to now, the AS is completed.